Hello, I am Aniket from Tarkashastra Academy. In this session, we are going to look at Basics of Mathematics, Session 5. The main agenda today is comparison of fractions and divisibility rules. Okay, let us move to the topic. Comparison of fractions. How do you compare fractions? If I have to see whether 8 by 11 is greater or 10 by 13 is greater, I have to check which of the following fraction is greater. How will I do that? I will just take the denominator to the numerator and multiply. It is 104. Take this denominator to numerator and multiply it. It is 110. 110 is greater, so 10 by 13 is greater. As simple as that. There is one thing that you have to understand here properly, that you have to always take the denominator to the numerator, not the other way around. So you cannot bring 8 to 13. This is wrong. You have to take 13 to 8. Okay. Next, let us say if I have to check any improper fraction, so 7 by 5 and 11 by 8. Which fraction is greater? Which fraction is smaller? We have to understand this. So what I'll do? I'll take this 7 into 8, 56. Again, if you observe, I am taking the denominator to the numerator, not the other way around. 7 into 8, 56. 5 into 11, 55. 56 is greater, so 7 by 5 is greater. Whichever product is greater, that fraction will be greater. It is as simple as that. Okay. I hope you have understood the comparison of fractions. Here we just have to tell which fraction is greater, which fraction is smaller. Now, compare the following fractions. You have to pause the video and start solving these questions. You have to answer all these questions and then come back to the solutions. Only if you do this exercise, then this video will be fruitful for you. Or else it will be just like another video where you have watched it but have not gained anything from it. So if you really want to gain something from this video, make sure that you pause the video and try this exercise. So first is 7 by 8 and 9 by 10. Let us multiply it here itself. So this is 70. This is 72. 72 is greater, so 9 by 10 is greater. Then 11 into 10, 110. 8 into 13, 104. 110 is greater, so 11 by 8 is greater. 17 into 7, 17 into 7, 17 into 7 is 119. And 13 into 9 is 117. 119 is greater, so 7 by 13 is greater. 16 into 30 is 480. 25 into 20 is 500. 500 is greater, so 20 by 30 is greater. 20 into 17, 340. 18 into 19, 342. 342 is greater, 19 by 20 is greater. 27 into 40, 1080. 38 into 29, we'll have to do it. 38 into 29. 29, 72, this is 27, 34, 0, this is 76, 2, 0, 1 carry, 1102, 1102, this is obviously greater. Then 17 into 34 is 289 ka double will be 578. And 24 into 27, 576 plus 72. So this is 8, 14, 1 carry, 648. 648. Obviously 648 is greater, so 27 by 34 is greater. 12 into 40 is 480. 18 into 24, 18 into 24 will be 180, 360, 72, 432. 432. 480 is greater, so 12 by 18 is greater. 51 into 12 is 510 plus 102, that is 612. 52 into 11, 520 plus 52 is 572. 612 is greater, so 51 by 52 is greater. Then 14 into 17 will be how much? 17. 170 plus 68. 238. 15 into 16 is 240. 240 is greater. So 16 by 17 is greater. This is how you can compare the fractions. This comparison of fraction will be very much useful in data interpretation. Okay, moving forward to divisibility rules. Divisibility rules we have studied in our childhood. So we have studied divisibility rule of 2, 3, 4 and all. So what is the divisibility rule of 2? Last digit must be divisible by 2. Divisibility rule of 4, last two digits must be divisible by 4. 8 की divisibility, last three digits must be divisible by 8. 16 की divisibility, last four digits must be divisible by 16. Divisible by 16. Then 3 की divisibility is sum of digits must be divisible by 3. 9 की divisibility, sum of digit must be divisible by 9. Then 5 की divisibility, last digit must be 0. 10 की divisibility, last no 5 की divisibility, last digit must be 0 for 5. 10 की divisibility, last digit must be 0. Okay, we have seen this. We know these divisibility rules since our childhood. Then what is the divisibility rule of 6? So it is 2 and 3. If a number is divisible by 2 and also by 3, then the number is divisible by 6. We say this. Okay, there is a big logic over here. We have to understand co-prime numbers and everything. But this is basics of mathematics session. So we are going to understand what we already know. Okay, these things we have studied in our childhood. Now, when we study numbers chapter, in that case we will be studying. In that case, we will be studying about the divisibility rules. Okay. Then comes 12 key divisibility. So if a number is divisible by 3 and 4, then the number is said to be divisible by 12. So again, co-prime number logic is applied over here. Okay. Co-prime number logic is applied over here. We have to take that into consideration. Okay. Now pause the video, try to solve these questions. We are continuing from here. Which of the following numbers are divisible by 2, 5 and 10? So 149 not divisible by 2. This is divisible by 2, not divisible by 2, divisible by 2, divisible by 2. Then divisible by 5. So this is divisible by 5, this is divisible by 5, this is divisible by 5. Is this divisible by 10? Yes, this is divisible by 10, divisible by 10, divisible by 10. So numbers divisible by 2, 5 and 10 are this one, this one, this one. Second, fourth and fifth. Check whether the numbers are divisible, not divisibility, not divisible by 4 or not. So 0, 8, divisible by 4. How do we check the divisibility of our last two digits? So 08 divisible by 4, 46 not divisible, 72 divisible, 26 not divisible, 24 divisible, 00 divisible, 38 not divisible, 36 divisible. As simple as that. You just have to check the divisibility of last two digits. Okay, we will understand the reason behind it. But then since childhood we have been doing it like this, so let us continue in that fashion. Next, if each of the number in each of the following numbers without doing actual division, determine whether the first number is divisible by the second number. And you don't have to do the actual division. You just have to check whether the first number is divisible by the second one or not. So 340192, is it divisible by 6? So is it divisible by 2? Yes, it is divisible by 2. Is it divisible by 3? So this is 7, 16, 17, 21. So divisible by 3. So if a number is divisible by 2 and 3, it should be divisible by 6. For a number to be divisible by 6, again 2 and 3. So this number is divisible by 2. This number, this is 8, 10, 11, 19, not divisible by 3. Okay, 8, 10, 11, 19, not divisible by 3. So this number is not divisible by 6. Then what is the divisibility rule of 8? Last three digits. 634. It's not divisible by 8. So the whole number is not divisible by 8. Then comes 72. 712. Again, we have to check the divisibility by 8. So we check the last three digits. 712. If you do this calculation, 712 is properly divisible by 8. That means it will leave a remainder of 0. So 712 is properly divisible by 8. Hence, this number satisfies. I mean, first number is divisible by the second. Then 3501804. Is it divisible by 4? So for 4, we check the divisibility of last two digits. Last two digits 04 divisible by 4. So the whole number is divisible by 4. Next thing that we have to understand here is fourth question. 6 is a factor of this and this. First, let us check. 6, is it a factor of this? So yes, divisible by 2. 15, so divisible by 3. So 6 is a factor of this. Divisible by 2. 13, 16, 18, divisible by 3. So 6 is a factor of this. Now is 6 a factor of this plus this? So what is the addition? What is the addition? 6, 8, 3, 11, 1 carry, 6, 1, 3, 8, 6. Now, is it divisible by 6? So it is divisible by 2. It is divisible by 3 as well. Total is 24. So definitely divisible by 6. Now let us take the difference of these two numbers. 1, 2, 0, 6, 6. The difference is 4. This is 5. This is 2. This is 7. And this is 3. 10, 12, 21. So divisible by 2, divisible by 3. So definitely divisible by 6. Now we have done this activity over here. But hereafter you have to remember that if two numbers are individually divisible by another number, then their sum and addition is also divisible by that number. For example, n1 is divisible by x, n2 is also divisible by x. Then n1 plus n2 is divisible by x, and n1 minus n2 is also divisible by x. And n1 plus n2. So the numbers addition is also divisible by x, and numbers subtraction is also divisible by x. Okay, so I hope you have understood this fourth question as well. Now, is 9 a factor of the following? So what is the divisibility rule of 9? we have to check whether the sum of the digits is divisible by 9 or not. So 3 plus 9 plus 4 is 16, 22. 22 plus 8 is 30 plus 3, 33. Not divisible by 9. Here, sum of the digits 9, A, 18, 27, 33. Not divisible by 9. Then 5 plus 1, 6, 13, 15, 18, 27. Sum of the digits is divisible by 9. Hence, the whole number is divisible by 9. That's it. This is how we need to do it. Okay. Now, coming to this page, you just have to write whether the number is divisible by that particular number or not. You simply pause the video and solve this table. You can write y and n and you will be done. It is a very easy table. Pause the video and try to do it yourself. Only then this session will be fruitful for you. So 28 divisible by 2, yes. 36 divisible by 2, yes. 56 divisible by 2, yes. 144 divisible by 2, yes. 303, no. 756, yes. 1000, yes. 8000, yes. 1455, no. Now let us check the divisibility by 3. 28 divisible by 3, no. 36 divisible by 3, yes. 56 divisible by 3, no. 144 divisible by 3, yes. 303, yes. 756, yes. Total is 18, no. This is no, this is no, this is yes. 1455, total is 15. Now let us check the divisibility by 4. 28 divisible by 4, yes. 36 divisible by 4, yes. 56 divisible by 4, 144 divisible by 4, 303, no. 756, so is 56 divisible by 4, yes. 1000, yes. 8000, yes. 55, 1455, no. Let us check the divisibility by 5. 28 not divisible by 5. 36 is not divisible by 5. 56 is not divisible. 144 no. 303 no. 756 no. 1000 yes. 8000 yes. 1455 yes. Now divisibility by 6. If the number is divisible by 2 and 3, then it will be divisible by 6. We don't have to check these numbers. If I have yy over here, that means the number is divisible by 2 and 3. So it will definitely be divisible by 6. So I have y and n, so not divisible. I have y, so divisible. Y and n, not divisible. Y, divisible. Y and n, not divisible. Y means divisible. Yn, not divisible, not divisible, not divisible. As simple as that. Now let us check the divisibility by 8. For 8, we check the last 3 digits. But here the numbers are small, so we will directly check. So 28 divisible by 8, no. 36, no. 56, yes. 144, 120, yes. 303, no. 756, 756. 72, 36, no. 1000, yes. 8000, yes. Many people get confused over here whether this is divisible or not. So yes, it is actually divisible. Then 1455, no. Now divisibility by 9. Some of the digits should be divisible by 9. So 2 plus 8, 10, not divisible by 9. 3 plus 6, yes. 5 plus 6, no. 144, yes. 303, no. 756 is 18, yes. 1000, no. No. 4, 1 plus 4, 5, 15, again, no. So this is how we have understood the comparison of fractions and the divisibility rules. I hope you have gained something from this video. Make sure that you apply it in the actual exam level questions. Only then it will be fruitful. If you have any query, please post it in the comment section. Thank you so much. Jai Hind.